The last section in chapter 4 that we're going to be covering is called numerical integration, and there's something called the trapezoidal rule, which we're going to use, like it says, when we don't have simple antiderivatives. It is always with a definite integral from a to b, and if we don't know how to take the integral of it, we're going to use the trapezoidal rule. So what it is you find b minus a over 2n is going to tell you what n is, and it's going to be the number of intervals you're going to use, and then it's going to follow this certain pattern. Now it's going to make more sense to you if I just go right into it, and the bigger n gets, the more approximate the trapezoidal rule is. If you have n equals 4, it's going to be less accurate than if n is 100. Since we have to do this by hand, however, it's going to be more beneficial to use smaller values of n, but it will tell you what they are. So first we're going to use the trapezoidal rule to approximate 0 to pi of sine x dx. Now the good thing about this is that we know how to take the integral of sine x dx, so we can check our answer and compare it. So first one, n equals 4. Well, we have to do b minus a over 2n, like we said. So it's going to be pi over 8 for the first one when n is 4. And then we multiply that by, and the rule says f of 0, f of x1, f of 2, f of x2, and so on. So the first and the last are not going to have 2's in front of them, but everything in the middle will. So if n is 4, we need to figure out what those intervals are. So if we're splitting up 0 to pi, our intervals are going to be 0, pi over 4, pi over 2, 3 pi over 4, and pi. As you can see, there's 5 numbers, but there's 4 intervals. So 0 to pi over 4, pi over 4 to pi over 2, so on. So we're going to plug in those values into our function sine x. So we're going to have sine of 0 plus 2 times the sine of pi over 4 plus 2 times the sine of pi over 2 plus 2 times the sine of 3 pi over 4 plus sine of pi. So as you can see, only the first and the last do not have 2's in front of them. That's going to be the pattern for the trapezoidal rule the whole time. You're going to type this into your calculator, and it will be approximately 1.896 if you plug it in correctly. It might be hard to plug in all at once, so if you want to just plug in each individual term and write down an answer to 4 decimal places or so, then you'll get pretty close to the same answer. Okay, now let's do an n is 8. If n is 8, our intervals are going to be 0, pi over 8, pi over 4, 3 pi over 8, pi over 2, 5 pi over 8, 3 pi over 4, 7 pi over 8, and pi. So same interval, only we have 8 subintervals instead. So b minus a is again pi over 2n. This time it's going to be 16. Sine of 0 plus 2 sine pi over 8 plus 2 sine pi over 4 plus 2 sine 3 pi over 8 plus 2 sine pi over 2 plus 2 sine 5 pi over 8 plus 2 sine 3 pi over 4 plus 2 sine 7 pi over 8 plus sine of pi. Plug in that whole thing and you should get approximately 1.974. So obviously it went up a little bit when our n was bigger, and it will become more approximate. You can check your answer using the antiderivative of that one. Most of the time you're not going to be able to check your work except for on a graphing calculator. Okay, so there can be errors in the trapezoidal rule, and the way you figure that out, your error is going to be less than or equal to b minus a cubed over 12n squared. So again, n is going to be your number of subintervals times the max of your double derivative, sorry. F double prime is your double derivative. Okay, so on this one, let's find the double derivative first. This is 1 plus x squared to the 1/2. F prime is 1/2 x plus x squared to the negative 1/2 times 2x, which is x times 1 plus x squared to the negative 1/2. And our double derivative, we need to do the product rule. 1 plus x squared to the negative 1/2 plus x times negative 1/2, 1 plus x squared to negative 3/2 times 2x, which is 1 plus x squared to negative 1/2 plus, I guess we could just do minus because it's negative x squared. 1 plus x squared to the negative 3/2. Okay, so we need to find part of the error is getting the max of this. So max of f double prime on their interval from 0 to 1 is at 0, 1. So our max value is 1, the y value there. So if our error is less than or equal to b minus a cubed over 12n squared times the max of f double prime, that's going to be 1/100th is less than or equal to 1 over 12n squared times 1. Cross multiply here, 12n squared is greater than or equal to 100, and n is greater than or equal to about 2.89, which we will call 3. So we have to have at least 3 subintervals to be within 1/100th for the error. Right, so that's actually all we have in the trapezoidal rule. We just have doing the trapezoidal rule itself and then finding the error. And that is all for chapter 4.